why is it called rational? Well, it's rational science instead of just science because we do something different than everybody else on planet Earth. We are the only people who do something different. And you might say, you're boasting, Bill, you're bragging. No, I'm stating a fact. We do something that's totally different from everybody else. What's different? Well, in a general sense, what we do here, we move objects. Everybody else moves concepts when they're explaining physics, okay? And that's what's different from this side. Here we talk about objects, okay? You can't do physics without objects. You know, there's a lot of people who come here and they say, look, I like what you say. You know why? Because what they're looking at is my criticism of the establishment, okay? So when you criticize the establishment, there's a lot of people out there who do not agree with the mathematical establishment. They say, Bill, you know, I'm with you. We're on the same wavelength. We think alike. And the answer is no, we don't. And until you realize what this site is really about, you know, you're going to have problems. It's going to take a while for you to really come up to speed, okay? Because we do things that are different from every other site, and people think that this is science as usual. So we got to look at what's different about this site as far as science is concerned, let alone physics, okay? So we have a different notion of what science is supposed to be. We're trying to get rid of the last 400 years of science. We're saying none of that was science. Science is something else, okay? And physics is very tied with that. Okay, so one of the things that we are not, but that's not science. We are critics. We criticize the establishment. But science is not about criticism. Science is not about skepticism. Okay, that's not a scientist. What is a scientist? A scientist is someone who explains rationally. Okay, so if you're a skeptic, if you question the establishment, you're a critic, you criticize the establishment, you're still not a scientist. You're just a critic, and a critic is not a scientist. Okay, if you want to be a scientist, you need to explain. You have to offer something in exchange that is rational. If you offer something that is rational, it had better not involve the movement of concepts. I hope that's straightforward, okay? So we need to figure out what an object is, what a thing is, and what a concept is. And that's where we have big problems. And we discussed some of that last week, okay? So let's summarize here and find out what science is about according to this site, okay, here. Okay, science, rational explanations. Okay, straightforward. If you are explaining rationally, you are a scientist. Do I believe in your theory? Is your theory has been proven? Have anyone verified it? Have we run an experiment to confirm your theory? If your theory is rational, okay, it's science. If it's irrational, we don't care how much evidence, how much proof you have, how many people raised their hands and voted for your theory. We don't care about any of that in science. Science, rational explanations. That's it. That's the only thing that includes within science. What is rational? Well, we move objects, not concepts. And we're talking about physics here, okay? Not about philosophy. We'll get to that in a second here. But we move objects. Okay, you can say you move the rock from A to B. We all understand that. We have the rock there. We can make a movie of it. We understand what you're saying. But if you say you move love, well, we have a big problem there. Even worse, if you say you moved energy, you transferred energy, oh man, now we have a real problem, okay? Because energy is not a physical object. But all these people have that language. And that's the big problem. The problem is language. And until people understand that the problem with mathematical physics is 99% language, what do they call it? Semantics, ontology, philosophy, I don't know what they call it. Any of those, they're talking nonsense. We either do rational physics or we do irrational physics. And the movement of concepts is irrational, period. We're done. So we need to know what the difference is between an object and a concept. The only two category of words that exist in the dictionary. No word falls outside of object or concept. If you have a separate category, we need to discuss. we need to discuss your version. Okay. One of the things that a lot of people don't like, in fact, dissonants, a lot of them, they don't like the rigorous, rigid definitions. Because as soon as we define what an ether is, what plasma is, they start running away. They say, oh, well, but you're doing ontology, semantics, and whatever, and they lose their brains. No, we need rigorous definition. We need to know what an object is, what a concept is. If plasma, ether, the words of the dissonance, are concepts, you cannot use them in physics. I'm sorry. I hope it offends you. I hope you run away with your tail between your legs. You got to run out, because those are concepts. They're not objects, and we'll get to that. And then the other important thing for rationality is that the theory follows from the assumptions. You make a hypothesis. You present the objects, the definitions, and the initial scene. Those are part of the hypothesis, right? Once you present that, people can follow. Okay, you can put God. You want God? I'll put God. God is an object. There's this guy with a magic wand, no problem. We put him there. We can see him there with his magic wand, no problem. Rigorous definitions, you define heaven, you define the angels, God, you can define anything you want, no problem. And then the theory that you present has to follow from those assumptions, those objects and definitions, okay? And I always like to say, you don't want to present, you're the prosecutor, you don't want to present a knife and then do your theory with poison. Say, well, the person was poisoned to death. So why did you present the knife, and that sort of thing. It's got to be consistent. Okay, how about explanations? What is that? An explanation is not a description. It's not a series of descriptions. It's got nothing to do with descriptions. Explanation has to do with physical interpretations. Physical interpretations of what? Of causes. If we're talking physics again, causes underlying a phenomenon. Something happened, you want to explain it, you need to have the causes. What caused that to happen? That's what physics is about. Okay? Science is divided into disciplines, parts, whatever. We have physics and philosophy. What is philosophy? Well, reasons and purposes. Why someone did something, how someone behaves. Okay? Say, Bill, that's not what philosophy is. We have Aristotle, we have David Hume, we have, Immanuel Kant and all these other people. They had another notion of philosophy. Yeah, they were not philosophers. They were not philosophers. In fact, you have people like Ayn Rand, right? And she did politics. That's religion. It's got nothing to do with philosophy. Okay? If you go to the university and you study philosophy, what did you study? Well, a lot of people say, well, we study ontology. We study what does exist mean? What is an object? No, those words belong exclusively to physics. They were stolen by people who knew no better, and they put them under philosophy, among them Aristotle himself. Okay? No, the words object and exist belong exclusively to physics. Anyone using those two words, whether they know it or not, has stepped the line over into physics. They are now talking physics, not philosophy. Philosophy, only behaviors, okay? Reasons and purposes. We don't deal with that here in this site. We deal with just that left side here, there, physics, causes and mechanisms, okay? So that's what we try to explain. If you want to explain a mechanism, you had better have objects. You can't do it without things. If we erase all the things from the universe, there's nothing happening, literally. Nothing's happening, okay? So you need objects to do phenomena in physics, to do physics, right? Okay, these are the foundations that we propose for science, for physics specifically. Foundations of physics, okay? We begin with the golden principle of physics. You can't do physics without an object. Period. We're done. Or exclamation mark there, better still. You can't do physics without an object. If you don't have an object, you can't do physics. Nothing's happening. So you can't put a concept and replace the object with a concept and say, I'm going to do it with a field. I'm going to do it with energy or mass or time. No, you cannot replace objects with concepts, move them around and say you gave a physical interpretation, that you explained the cause of something that happened. Okay? Object, there you have the key words for the foundations of physics. You can't do physics without them as far as I'm concerned. I don't know if I'm missing one or maybe putting one too many. Those are the ones I propose. Object, that which has shape. Space, that which doesn't. Period. One is something, the other one is nothing. They're antonyms. Now we can use those words consistently, rationally, scientifically. Okay? Distance. What is distance? Separation between two objects. What is location? It's a set of distances from one object to all the others in the universe or in the system that you're analyzing. Doesn't matter, right? So no problem as long as you know what location is. Set of distances. There has to be a distance between my chest and God's chest. There has to be a straight line of direction between my chest and God's chest. I don't care where God wishes to hide. He can hide in the 26th dimension for all I care. There had better be a straight line of direction from me to him. He cannot escape that straight line, okay? Period. We're done with that. I mean, if you don't understand that, I cannot help you. Location, the set of distances. One atom or whatever system you want to analyze to all others, right? And the set of distances, that's the location of that object in the universe. In the universe, okay? We're not talking about math here, about position, ordered pair or triplet or whatever. None of that nonsense. We're talking about physics, set of distances from one object to all others, okay? Exist, physical presence. What does that mean? Object that has location, okay? Then it exists. God is an object. If he looks like a man, with a magic wand, no problem. We put him there and say, that's God, okay? So far, he met the condition of object, of thing. Now he needs location. If God wants to have location, there had better be a straight line of direction from me to him. If there ain't, God does not exist, not because I believe or stop believing or I doubt or whatever. No, it's got to do with the fact that God does not meet the definition of exist. Exist, object that has location. There has to be a set of distances to all other objects in the universe. Then God exists by definition. Period. We're done. So when you say, let us assume, not, I believe that God exists. I know that God exists. Or I know that God doesn't exist, or he doesn't, or I don't know if God exists. No, none of that has any validity in science. Okay, in science we say, let us assume that God exists. Okay, we make an assumption that there is an entity called God and that he exists. What are we saying? We're saying that God has location. There's a set of distances between God and every atom in the universe. Then God exists by definition in your theory. Okay? Motion, two or more locations of an object. You need objects before you can define the word motion or location for that matter. Object is the first word you need to absolutely define before you can define all these other concepts. And as you can see, they're all concepts because they're all defined. None of those are objects. None of those words represent objects. I can't point to object. I can point to a stone, which is an object. Stone is within the category called objects, but none of those words represent objects per se. Okay. Motion, two or more locations of an object. Okay. You need two locations. You got it made. You got motion. And that means it changes its location, set of distances with all objects in the universe. That's physics. And concept, a word that invokes or embodies two objects. Takes a long time for people to understand the word concept. Object is easy, but concept, they have no idea what a concept is. Nobody's ever defined these words, by the way, and these form the foundations of physics. Okay, so we have one fellow, and he's at the following. He doesn't like the explanation that I gave. So he says, Gaede's explanation makes no sense to me. Okay, I'm so sorry. I can't come down to your level, An alternative. He's going to offer an alternative explanation, okay, to mine. And I think he checked an AI of some kind, meta AI. Fine, okay, no problem. And I don't know if he got that from the AI or this is his conclusion. He says, lack of mechanisms. In other words, the explanations it's a lack of mechanism no known physical processes can explain. And he goes on, blah, 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 blah. Okay, so he's going to explain something, but he's got an alternative explanation. The explanation is that he's got no explanation. In fact, he says it on the next line. I don't have a mechanism that explains, like the atom of gravity. Okay, neither does any physicist at present. We only have theories. He doesn't realize that a theory is an explanation. So he's saying no one has an explanation. We only have explanations. That's all he said. And these people have these are the type of people I get here. Sometimes it's unbelievable. These theories, explanation, right, do a significantly better job at explaining. So he's constantly contradicting himself. He's going in circles. He's getting tangled in his own verbiage there. And that's the problem with a lot of people. They don't understand how important language is. You know, they just keep rolling around, chasing their tails around like a dog. Okay? That's what they're doing. And so, yeah, I don't know what it is that he cannot understand of my theory. My theory is for babies, kindergartners, maybe a baby is too early, but kindergartners for sure. Kindergarten can understand my theory, okay? And let's go through it very, very quickly because that's not the point of the discussion. Here it is, the electromagnetic wave, Maxwell's wave, right? The transverse wave, we replace it with a rope. We're saying that what all these people have been doing for the last 200 years is looking at a rope and calling it a wave. What's the wave? An electromagnetic wave. And what are you staring at when you look at an electromagnetic wave? Well, you're staring at this, okay? This is what you're looking at. You're looking at the electric field and magnetic field. They run at 90 degrees to each other and embrace an axis for no reason that anyone can tell us. For some reason, it just goes on an axis, straight line, right? And what are you staring at? Well, all those arrows there, they're vectors. They're not engine arrows, they're vectors. What is a vector? Magnitude and direction. Magnitude belongs to math. Direction belongs exclusively to physics, does not belong to math. You cannot put the word direction in an equation. So that's the math phys part. They kind of put them together, merge them forcefully together. But what you're staring at is a mathematical concept. And the funny thing about that is that they have this wave and it's moving. This is what's funny about it, because they have these vectors, right? The electric and magnetic field. And what do? They have them moving from A to B in one direction always, right? Okay, so this is, I don't know what you should call this, irrationality. What are you going to call it? Okay, so the electromagnetic wave, the transverse wave, moves. So you have all these vectors, these numbers, because that's all that you're staring at. Those arrows represent numbers, and they're moving. So you figured it out. What's a field? I mean, a field is made up of all these vectors. What are we staring at? A field is what? A value at each point in space. Okay, so what we're staring at is concepts, mathematical concepts, and they're moving. All these concepts are moving. That's all irrational. We're replacing it with a physical object. We're not talking about fields anymore. We're talking about a thread, strand, fiber, call it whatever you want. You know, I mean, wire, okay, strings. I call them threads, okay? Is that good enough for you? You know, I mean, we have two threads. And as you can see, they embrace, if it's a taut rope, in this case, right? Taut rope, they naturally embrace an axis, a straight axis. So we have a taut rope, okay? Here I have my model, okay? Okay, you have the rope there. It's also blue and red. And if you pull it very tight, you can imagine an imaginary axis running right through the rope. Okay, that's why light travels straight, because light is going to consist not of one-way motion of waves, of vectors, right? All these fields. No, it's going to consist of torsions, in situ torsions of the rope. Okay, and here, let me put the mechanism so that you can just visualize it. Here it is, very simple. Let me get rid of this one. Okay, and here you have it. Oh, I got rid of the wrong one. Well, anyways, that was it. Sorry. How do we construct this thing? Well, here it is, the construction of the rope, okay, and the atoms that make it up. Here you see it, okay. You can see the two threads. They build the atom itself, okay, and one coils around, forms the electron shell, and the other one goes through and forms the proton, dandelion, or star, whatever you want to call it. There you is. And every atom, every rope in the universe converges upon our atom. And that's what it looks like, more or less. Here it goes one more time. Okay. We'll see it in a second here. Okay, the two threads of a rope. Okay, they coil around. One coils around, the other one goes through the center. Okay, so the two threads are accounted for. They come out the other end. And one builds this encapsulating membrane. That's what the electron is. It's a membrane, a shell. It's not a little bead that runs around. You have all the atoms in the universe, all the ropes converging upon our atom. Okay, so that's more or less the model. Okay, I'm not sure what this fellow does not understand about that. Okay, let me get rid of this. And so what we have is two atoms, and they're expanding and contracting. That's what I was showing you, the one I lost there. It's expanding and contracting, and by doing so, it torques the rope. And the rope forms part of the atom that it's connected to. And it's not connected to like attached. It's part of the atom. The ropes become the atom, okay? And so that's the model. There's a single thread in the entire universe. What it is that this fellow does not understand about that, I have no idea whatsoever, okay? I mean, we're not asking you to agree. We're asking you to understand. Do you understand the model? Okay, you don't have to believe in it. You can have your own model, no problem. Go ahead. But we want you to understand what we're offering in this site. We're saying, look, there's two atoms. That's the main model. It looks like a dumbbell, right? Two atoms united by a rope. The atoms expand and contract. By doing so, they torque the rope at great speeds. We're talking about something extremely fast. That's why light is so fast. Torsion is the fastest thing known to man imaginable. You cannot imagine anything faster than torsion. Okay, and torsion is not a thing, but it's the signal that propagates. It's like an optical illusion. It just hits the atom at the other end and gives it these little thumps. And those thumps are what we recognize as light.